Hi class, today we're continuing viewing applications of the derivative. So our class objective is to demonstrate the sum of a positive number and its reciprocal is at least 2. For that we have the next problem is find two positive numbers such as the second number is the reciprocal of the first one and the sum of both numbers is minimum. So think about how you can solve this problem. Any ideas? Well, that's a way we can, on one hand, we will have to guess the two numbers. So we're going to start by the number 2, that it's positive and its reciprocal is a half. And if we add them, we'll have 5 halves or 2.5. Well, that's a way, and we can see there is 2.5. That's the sum of the two numbers. But what if we go down a little and we write another couple of numbers, like I don't know, like a third? We can think that if we choose a number between 0 and 1, we have a little and it's a very small number, but its reciprocal is 3. So what we'll have 3 times 3 plus 1 we'll have 10 thirds. And we can now say that we can just approximate that into how to say that 3.3 periodical. So if we notice, we have that 3.3 is greater than 2.5. So maybe if we choose a number greater than 3, then we won't be finding the minimum sum of this. So this is a way, but we cannot be sure if we're trying the right numbers. But what if we find another number that is smaller, that its sum with its reciprocal is smaller than 2.5? So we cannot be sure. For that, we're going to go on the other way. On the other hand, we have a model. So I'm talking about right here, a model. And we'll have to use algebra. And we'll say that the first number is x. So in the problem, they say that the second number is the reciprocal of the original number. So we'll say that 1 divided by x. So what if we represent the sum of these two numbers? We'll have x plus 1 divided by x. And we'll name that as a function that depends from x. So that function is what we'll have to find the minimum of the function that corresponds to the minimum sum of the two numbers. So we're going down a little more, and we define f, and we can say y equals to x plus 1 divided by x. So that will be our function, our f that depends on x. So the first derivative when we have x is only 1, and then we have x to the power of -1. So we apply the rule of the power and we'll be having minus 1, we maintain this 1, and we divide it by x to the power of 2. So we're saying we also need the second derivative, and we'll have derivating y, the first derivative of the function f. So the derivative of a sum or an addition is the addition of the derivatives. The derivative of 1, for example, is 0, and then we will have to add the derivative of minus 1 divided by x to the power of 2. And it's not hard to notice that we'll have x to the power of minus 2, and the derivative of that is a minus previous the minus 1 at the numerator, and then we add minus 1 to the exponent. So what we're finally keeping is 1 divided by x to the power of 3. That will be the second derivative of f. Well, we'll be looking for stationary points, and if you don't remember, stationary points are those like here or here when the derivative is 0. So there we have a relative minimum, and then we have a relative maximum of the function f. That will be f for us. Here I'm right. So the derivative of the function is 1 if and only if 1 minus 1 divided by x to the power of 2 equals to 0. But it happens if and only if we're going to add these two fractions, and we'll have x to the power of 2 minus 1 divided to x to the power of 2 equals to 0. Then we'll be having that we cannot have, for this to exist, notice that x is different to 0. That's an important point, but if we have any number divided by 0, we cannot define it mathematically. It's not known what this number represents, what a division of by 0 is. So it only happens if the numerator, and we're going to factorize it here, equals to 0. So it happens if and only if x equals to 1 or x equals to minus 1. But if you notice, they will asking us for a positive number. So we're going to choose x equals to 1 because minus 1 is smaller than 0. So that will be the only stationary point we are going to consider in this time. So the only thing you need to do is to apply this secondary theory. And what you'll have is that the derivative of a point C, if the derivative of a point C is greater than 0, then C is a minimum of the function. So what if we evaluate the first derivative of 1? We'll have, if you remember, 1 minus 1 divided by 1 to the power of 2. I'm sorry, we're talking about the second derivative. So the second derivative of the function, evaluating in 1, is 2 divided by x to the power of 3. So in this case, we'll have 2 divided by 1 to the power of 3, which equals to 2. And 2 is greater than 0, so we can conclude that the number two is a minimum of the function. And what does our function means? Well, we need to remember that our function is the sum of the number 1 plus 1 divided by this number that is 1. So we have 2, and 2 is the smaller sum of a positive number and its reciprocal. So we only apply the first and the second theorem, and then we find out that 2 is the smaller sum of numbers. Therefore, we have achieved a big prize for that. It's very useful to know that the sum of a number and its inverse or its reciprocal is greater or equal than 2. We can use it in algebra, in calculus, or even in geometry. So you need to remember this result and use it as much as you can. So for the next class, all you will have to do is to bring another optimization problem. And well, we cannot do all the optimization problems of the class, but we can choose some interesting problems that you bring from all of you. We're going to decide it as a group, we're going to vote, and we're going to work on them only by using the second and the first derivative theorem. So class, that will be all for today. Let's see that we have finally completed our objective for the class. So see you next week. Bye class.